Welcome to Luxoft Tech Talks, a series of podcasts in which IT gurus share their knowledge and discuss the latest trends and innovations in the world of IT. We are going to cover the most recent developments in the programming languages, frameworks, and technologies that are shaping the future of the software industry. This new format of online learning is part of Luxoft Learning Management and Development Services rebranding. Please share your feedback in the comments to let us know what speakers and topics you would like us to cover in later installments.
Hello everyone, and welcome to this Luxoft Tech Talk. My name is Hanno, and I work at a company called InfoSupport, and I work there as an IT consultant. Now, I'm from the Netherlands, and my company is also from the Netherlands, and I guess everything you've heard about my country is probably true. I mean, before we go to work in the morning, we put on our wooden clogs, and we never drive to work. We don't drive our cars, we ride our bikes, because everyone in the Netherlands rides his or her bike. Or if it's winter and there's ice on the water, we will ice skate to our work. And also, on our daily commute, we will easily pass 10 different windmills. And when it's lunchtime, the office cafeteria serves stroopwafels only. And stroopwafels are a very delicious Dutch cookie. That's the only thing we eat, nothing else. These are stroopwafels, by the way, if you've never seen them. So if you're ever in the Netherlands, make sure to grab a few of these, or just become friends with a Dutch person, and they will very, very quickly give it to you. Also, when I'm speaking abroad on conferences, I will most of the times I will bring them with me. So if you want to taste them, invite me to your conference. If you like this talk, I will bring them and make sure you get some. So of course, this one being an online talk, it's rather difficult for me to bring them, but next time I certainly will. So I already told you that I am an IT consultant. Now, besides doing consultancy work, I also teach a few courses. At my company InfoSupport, we offer a wide range of courses. We have a learning center and a lot of colleagues that start out with us, or graduate students who want to graduate and do a research assignment at our company. They will be enrolled in these courses, and they will learn a lot of things. And we'll get them up to speed with important concepts on software development, for example, object orientation, basic Java or C# programming, automated testing, continuous delivery, containerization, infrastructure as code. All those kinds of topics will pass when they are doing these internal courses. And I'm a teacher also at a lot of these courses, and one of the courses I teach is called Git for Developers. It's a one-day course where I teach the students how to use Git, the version control system, as a developer. And if you're using a version control system as a developer, it means, in my opinion, to use the command line as much as possible. None of that GUI stuff, you know, no using source tree or the GitHub web interface. I really like the command line. I promote using it as much as possible, because it really rocks. It makes you more productive as a software developer if you learn these commands by heart. And also it makes you more understanding of your version control system, so you can understand what it does and how its internals work more quickly. Now, during the course day on Git, we also discuss the pros and cons of distributed version control systems, and also how they compare to the earlier version control systems like CVS or Subversion. This is actually one of the course slides that I'm viewing right now, and it displays which version control systems have emerged until now and when they became available. It also tries to put the publication dates of each version control system in perspective by comparing them to the most modern mobile phone known at the time. So to give an example, Subversion is right here, and it was published in the year 2000, and it relates to the Nokia 3210. I think we've all had this phone. I know I have. It was a very, very good one. You know, you couldn't break it. It always survived. It had a battery life of like a week or so. We can't imagine that right now with our smartphones. But so in the same year that everyone had a Nokia 3210, Subversion was published. And if you old CVS, it was created in the year 1990. It relates to this very ancient phone with the power plug, which is huge. Both are obviously ancient. CVS is ancient, and this phone here is also ancient with the power plug. Now, when I'm talking about this slide during the Git course, I tend to focus my attention to the events of the year 2005, which is right here, because to me, this year really stands out in version control history. I mean, there were 5 new version control systems published in that year, in just a single year. Let's put these facts into perspective. Before 2005, it had taken 9 years for 5 different version control systems to appear, starting with VSS in 1994 and ending with BitKeeper here in 2003. 5 different systems over the course of 9 years. And in 2005, another 5 systems were published within a few months. That's very remarkable. It always stood out to me. And it's very interesting to know why these things happen. Why did it happen like this? What kind of event took place that urged a lot of software developers to create their own version control systems? Well, this is actually what happened. This is a news item from April 5th, 2005. I got it from the web archive. You can still read it if you want. And this is about BitKeeper, the only distributed version control system that existed at the time. And it always was on a free license, so the open source world could use it. But this article states that because BitKeeper was growing so explosively, they wanted to change their licensing model. So to summarize, BitKeeper no longer was free to use. And of course, what happens when something is used and then is no longer free to use? You just create your own version control system, right? You create a new one. So in the aftermath of BitKeeper's licensing change, a lot of similar products were developed in a very short amount of time. And one of the products that was developed was Git, the new distributed version control system that we're also familiar with right now. And Git was created by Linus Torvalds, of course, the creator of the Linux operating system. And Mr. Torvalds himself was a user of BitKeeper, as you can see right here. Major project hosted at bitkeeperbits.net, such as the Linux kernel, will continue to be hosted and updated there. Well, this was true only for a very short amount of time because Linus Torvalds really wasn't happy about this licensing change. And in response to that, he created his own version control system, and he didn't continue to host his Linux kernel there. He just created his own system to allow himself to continue working on it. So, in summary, BitKeeper happened. BitKeeper came and gathered a number of followers and users, and then the licensing changed and a lot of new systems were developed. Well, as a course instructor, as a teacher, I really thought that this year really stood out in this graphic. So it seemed only logical to me to talk about this year. But not everyone thought so. So at the end of one particular course day, a student came to me with a question about this graphic. And her question proved that she had noticed an entirely different thing about this graphic than I had. Moreover, her discovery actually proved to be a lot more interesting than mine. And I thought my discovery was interesting, but of course I was wrong. So the student came to me after class and she said, I like Git and it's great and I like that I've learned about it, but what do I need to learn to be ahead of things? What is going to be the next big thing? So I turned around and looked at the chart for a while and I thought, wow, that's interesting. This was the only thing that stood out to me, nothing else, but the student that came to me with her question, what stood out to her was this part, 2010 and further. She noticed that virtually nothing happened after 2005, after this big hole of new version control systems. So she was kind of worried that she was learning something, a version control system that would be outdated in the near future. So I turned to her and I told her everything I knew. I told her I was quite sure that these distributed version control systems, and the most dominant at the time were Git and Mercurial, that they would be around for a while longer. But of course, it wasn't a proper answer at all, because I honestly didn't know what was going to be the next big thing. And afterwards, after I returned home from the course day, I really felt bad about not being able to answer her question directly. I had effectively told her that Git would probably be around forever, even if I didn't phrase it exactly like that. So I decided to research the matter a bit further because I wasn't satisfied with this answer I had to give her. And what started out as finding the answer to a simple question turned into an investigation, and the investigation turned into a conference talk. And the conference talk is the one you're watching right now. So welcome to you all, and let's see if we can find the answer to the question of my student together, shall we? And after we find out, I'll make sure that she gets the answer as soon as possible. Okay, I promise. Now, whenever I hear somebody say that some product will probably be around forever, like I said to my student, it immediately reminds me of this guy and what he said a while back. Boy, was he wrong. If working in software development for over 12 years has taught me anything, it's that change is the only constant. Now, this idea has been valid in our industry for as long as I can remember. And just think about it for a second, because you can come up with lots of examples. If you're working in an agile software project, you will see that requirements change. The first version of a user story is almost never exactly the same like the finished software product in the end. Priorities change. Just walk into a random sprint planning event and you will immediately notice that priorities change all the time. Dependencies change. If I've just finished migrating a big Java 8 project to Java 13, the latest one, and dependencies change. I have changed a lot of dependencies, had to update a lot of them to be able to make it work again. Or if you work in front-end development, browser behaviors will change all the time. You have to test for all new versions all the time. So to me, this proves, these are just a few examples, but these examples prove that in our industry, change is the only constant. So you can't really count on Git being around forever. There will be a successor. We just don't know when. It could be in 2 years, it could be in 5 years, it could be in 20 years. But eventually, there will be a successor, another version control system that will be more popular than Git and hopefully more usable. So it's useful to think about this kind of stuff. And we shouldn't just accept that let's learn Git because it will be the best thing for the next 50 years. We can't just assume that. So the question remains, which one will it be? Which version control system will be the next most popular version control system? And if we can tell before, it would be very useful to learn this version control system so that you can be on top of things and you can be innovative. Now, in finding the answer to this question, we obviously need to make a prediction. We have to predict which version control system will be popular in like 10 years. And throughout this talk, we will discover several ideas that can be useful for a prediction. I'm not just going to guess and say, well, it's going to be this one. I need some input. And these ideas, these input ideas, I like to call them prediction variables. I'll explain them a bit more later, but at the end of the talk, we are going to use these variables that we encountered to make the final prediction. And I think we can discover the variables we need for our prediction quite quickly by gathering information on the current big thing and how the current big thing became the big thing in the first place. So let's ask ourselves, why did Git become so popular? What happened? Well, as you all may already know, these are Git's main features. It's a distributed version control system, exactly like BitKeeper. You can commit often and you push only once, so you can work offline, for example. it's a free system. It's an open source system. Obviously, this is unlike Bitkeeper because they changed the licensing model and then you had to pay for it. It's very fast. Linus Torvalds himself, he said, everything you do with my version control system on a daily basis should take less than a second. And they really designed Git to perform like this. And it's optimized for branching. One of the first version control systems that had easy branching was Subversion. And this also responds to the CVS implementation of branching. In the CVS age, developers were really afraid of branching because creating a branch meant creating a copy of a directory. And if your repository is a large one or contains a very large number of files, this could take a while. I've worked with CVS for quite some time when I started out as a software developer, and branching of our like million lines of code base took like 45 minutes or something. You just clicked branch and then went downstairs, grabbed a coffee, grabbed another coffee, returned it, and your branch would be done. So we were really very afraid of branching. We tried to avoid using them. And nowadays, it could be feasible to not use branches if you have a good continuous delivery system in place, and you can get your new code content with your commit deployed to various testing environments, maybe even production in like 10 minutes, 15 minutes. Then it's okay. I guess you don't need branching. These changes can be isolated enough, can be tested quickly. But in the year 2000 or the 90s, this was a very bad thing that we were afraid of branching because we had no way to separate our functionalities. We had to use branching for that. We were stuck with branching effectively, and there was no continuous delivery system in which we could isolate a small set of codes and test them independently. So we really needed branching, but it didn't perform. So that was a big problem. So Git just said, well, let's do the opposite of CVS, and Subversion did a good job. So let's make branching also easy, like in Subversion. Now, when Linus Torvalds was asked why he called the new software Git, and Git is a British slang word, meaning a rotten person or a dumb person, he said, I'm an egotistical bastard, so I name all my projects after myself, first Linux and now Git. So he's mocking himself a little bit. He likes that. You should read the stuff he writes on the internet. He really likes to mock himself and others, by the way, but also himself. Also, I mentioned this before, but when he was developing Git, one of his guiding principles was WWCVS-ND, which means what would CVS not do? So take CVS as an example of what not to do, and if you're in doubt about a certain design principle, make the exact opposite decision of what CVS did. And following these principles, he arrived at Git eventually. Now I think we're ready to introduce our first prediction variable. And I think it should be killer features. And by killer features, I mean new features that have never been seen in the version control world, like Bitkeeper did with the distributed side of things. It was a big version control system until they messed up with the licensing. And a killer feature could also mean developing similar features like your competitors, but implemented differently, where a similar feature has been implemented in a radically different way to distinguish it from its competitors. And I think Git is a great example of killer feature because it was designed to be the opposite of CVS in many aspects, so new features. And also similar features, but working just a bit better, like branching is just a bit easier in Git. It's not necessarily a bit faster or slower than in Subversion, but it's a bit easier, and so easy and fast that you really want to create a lot of branches. And this is exactly what Linus Torvalds wanted. Also, we'll see in a bit on the popularity graph again, because Git was open source and distributed, it really helped the open source community cooperate a lot more, and it resulted in open source collaboration platforms like GitHub and Bitbucket and GitLab. And Git really made sure that a similar feature that was implemented a bit differently made sure that the version control system got a lot more popular. So let's return. So let's look at this popularity graph for a bit. This is some information on how Git became the big thing in the first place. Now there's a lot of significant information in this chart, and I'll try to zoom in on a few of them. So to start out, you can see that Git grew quite exponentially, but it also stands out to me that its growth started to increase rapidly after GitHub started supporting repositories for Git. So it was growing steadily, and then there was a GitHub launch, and then it grew a lot more, and then Bitbucket started supporting Git, and then GitLab Enterprise was launched, and then it went really through the roof. So it was really dependent on these hosting platforms. Also, what we can see in this chart is that Subversion peaked in the year 2009. So the most important version control system in 2009 was Subversion. But this was 4 years after Git and Mercurial were released. So Git existed for 4 years, and still Subversion was the most important version control system. And gradually, they lost track of it. Mercurial, which is like a very, it's a competitive product, but it's very much like Git. I haven't seen many differences, to be honest. They were released at the same time, and the reason they don't have many differences is because they are both based on the features of BitKeeper, because they are both meant as a replacement for BitKeeper. And what I can see in this chart is that Mercurial also grew in popularity, just like Git. And then it only started declining after Bitbucket said we are going to support Git repositories, because Bitbucket had been around for a few years, but it started out hosting Mercurial repositories only. So this explains the Mercurial growth until this point where Bitbucket said we will now support Git just like GitHub, and then the software development world decided we are going to use Git most of the time. So this explains the growth of Git and the decline of Mercurial here. Now, I would like to point out that although it's fun to look at charts like this is not actual data. It's very hard to discover the actual usage of version control systems. The popularity can't be measured like with browsers, for example. If you're doing a chart like this on browsers, you can just execute a JavaScript or maybe even HTML5 code that will analyze the user agents of your website visitors. But with version control systems, you can just peek inside everyone's computer and see what do you have installed or what do you use on a daily basis. So this data, these are all approximations. They were acquired by combining usage statistics from various sources. So you can see in the bottom of the chart, this is data from Google Trends, GitHub, Atlassian, and GitLab. So we have to take into account that these data are all estimates. And if we're going to base predictions on these estimates, then our predictions obviously also will be estimates. So that's the best I can do today for you. Can't promise anything, but I can do a prediction based on estimates. What I want you to take away from this graph is that hosting platform support is very important to a version control system's popularity. The major movements in this graph were all because of hosting platform decisions. GitHub is launched and Git grew. Bitbucket supports Git and Git grew more, and Mercurial started declining. So our next prediction variable, I think, should be hosting platform support. We've gotten used to this. If we use a version control system, we're used to being able to host a public repository and being able to push commits to it. So this has to be present in a successor of Git to some extent. So let's introduce another variable, because I already told you that Git really helped the open source community, or yeah, by creating the basis for GitHub and Bitbucket. And while it very well may be true that a version control system will be supported by a hosting provider, it doesn't necessarily mean that the hosting provider also supports the open source community. A lot of hosting providers at the start of their services offered private repositories primarily and not public ones. Also, not all version control systems focus as much on open source development as Git does. So I think we need this prediction variable because we saw that open source development also helps the popularity of a version control system. So if we would consider a new system that doesn't offer any open source community support, I think it won't be as popular as one that does offer it. So this is our next prediction variable. I think we've seen enough prediction variables for now. So let's try and make a first prediction. And of course, we're at a very, very early stage. I can only think of one approach to create a prediction, and that's what everyone in the world does. There are actually two types of people. And the first type is those who can extrapolate from incomplete data, which in fact is the only type of people in the world. So the only thing we can do is take some existing data and extrapolate it. And this is the data we have. So if we see in 2009, this was the case, Subversion was at the top, then Git second place, Mercurial third place, and then TFS followed closely by CVS. So this was the case. So I've put this into numbers like this: 43% for Subversion, 19% for Git, 16% for Mercurial, 6% for TFS, and 5% for CVS. If we follow the trend lines that we saw, and if we extend them to 10 years later, what will happen? Well, I think if Git started from here and it went to here in 2016, I think it will go a bit further in 2019. The opposite is true for Subversion. It went down, it went down, it went down. Well, the decline started to decrease a little bit, but it still went down, so it will go down a bit further. And then Mercurial the same, although it's not declining as rapidly as Subversion, so a little less decline, and TFS and CVS are effectively staying constant. So these are the numbers that I've come up with for 2019. Subversion is down to 8%, Git is up to 73%. I think this is correct because almost everyone that I talk to use Git, or some of them Mercurial, but a few less people than in 2009. TFS is kind of constant, and CVS has been on less than 1% for some time now, and I think it will be like that also in the next 10 years. If we want to extend this a bit further, well, then I think that the decline of Git will eventually start to slow down. Of course, it will. Sorry, no decline. The increase will eventually slow down because it can't be more than 100%. Of course, Mercurial will decline a bit more. Subversion will decline a bit more, and TFS and CFS will stay the same roughly. So this is my prediction until now, but it's a first prediction. I think so if everything stays the same and the trends that we've seen in the past years will continue, then Git will still be the largest version control system in 2029. Subversion will decline a bit more, and Mercurial will decline a bit more, and the rest will stay the same roughly. There's only one problem with this approach. This is why I called it a first prediction, of course. And it's that we haven't included any new products at all. The first prediction is based entirely on existing products, but a lot can happen in 10 years. What if a brand new feature-packed version control system appears and takes the market by storm? We have to account for that. And luckily for us, this isn't the first time that this has happened. This is exactly also what happened during the browser wars, multiple times actually. And when I was in college, I did a talk on the browser wars for one of the courses I was attending. And in this college talk, I tried to predict what browser we would be using 10 years later in time. So the talk I did back in college was actually quite similar to this one. But this one is about version control system. That one was about browsers. That was not the only difference. There was another difference, and that's the fact that my slide deck back then looked very different. This is actually one of the slides I used. It's in Dutch, but obviously that's not the worst thing. Notice the date in the bottom corner, February 2005. So the slide deck was created 14 years ago, and it shows it's a retro slide deck. I mean, look at the obnoxious headers, footers. They were repeated on every slide. disastrous, major waste of space. The background gradient, what's up with that? Nobody uses that anymore. Page numbers at the bottom, really horrifying stuff. I mean, maybe slide decks are like fashion, and if you would wait another 15 years, it will be popular again, or we should just forget about this slide deck design. Anyway, apart from the fact that this slide causes your eyes to sting and burn, it also shows that the Internet Explorer browser family was very dominant in 2005. Almost 90% of all internet users used a version of the Internet Explorer browser. Now, in this college talk, I predicted 3 things, and 2 of them actually really happened. These were my predictions. I said, in 10 years' time, I think Internet Explorer will be surpassed as the top browser family, which was quite a bold statement to make because 90% of internet users use this browser. I also said Mozilla Firefox will surpass Internet Explorer eventually, and I also said, I think Mozilla Firefox will be the top browser in 10 years' time. Just this last prediction didn't happen, but the other 2 did. So I have some credentials, you know, and here are the actual data. Of course, these were not present when I did the talk in college, but right now, of course, they are. I found this chart that started in 2007, and you can see the dominance of Internet Explorer here quite a bit. Firefox started to rise, but didn't rise as much as I hoped. But Internet Explorer was surpassed eventually. Here it is. This is the first time that Internet Explorer was surpassed, and it was surpassed by Google Chrome in 2012. And also Firefox, which is the black line, surpassed Internet Explorer for a very short amount of time right here in 2016. So technically it was 11 years later, not 10 years later, but it did happen. And I was quite sure that Internet Explorer would be surpassed because it had been popular for so long, and there were not a lot of new features. It kind of stayed the same. So I thought they are bound to be surpassed eventually by a better product. And I really thought at the time that Firefox would be the product, but I didn't really count on Google Chrome to appear. So I was right, sort of. I correctly predicted that Internet Explorer would be surpassed by a new browser, and it happened. So it's kind of the same situation that we're in right now in version control land. I mean, Git is the most dominant product. Of course, it's in development, but not really groundbreaking new features are introduced. So it's just a matter of time before a new product starts adding or thinking of better features and probably being more popular, just like Internet Explorer was surpassed. And the mechanism that I want to address here is the disadvantage of the dominant product. A dominant product in any market will get a lot of attention. Of course, positive attention, but also negative attention. For example, a lot of people are using on their desktop computers Microsoft Windows. And this is the reason why there are so many computer viruses that are targeted for the Windows operating system. So if you are building or if you are working on a very popular product, your product will most likely be a popular victim of malicious software, just like Windows. Also, if more people know your product, then they will also know the weaknesses. More people will think about how to fix those weaknesses, and more people will come up with fresh new ideas. So it's kind of like in sports, it's very hard to get on top. Sorry, it's hard to get on top of the table of a football league, for example. But it's a lot harder to stay there, to make sure that you still have the advantage over and over again. And eventually in time, your competitors will think of something to beat you. So this has been the case for browsers, it's been the case for football teams, and I think it will be the case for version control systems. So let's introduce our final prediction variable. It's very hard to stay on top. So if you're a dominant product, you have a disadvantage. In the browser world, this has been true. First we had Netscape, then we had Internet Explorer, then we had Mozilla Firefox, now we have Google Chrome. And I can't think of any reason why it shouldn't happen again. If Google Chrome stops making new features that everyone loves, then there will be a new browser that's going to be dominant. So let's keep this in mind, this final prediction variable, and let's investigate which new products we need to investigate as new successors, aspiring successors of Git. I have found 3 version control systems that were published after Git and are still alive as of today. So these 3 systems can be successors of Git. So we need to investigate them a bit further. Now these are the 3 I will talk about. They're called Plastic, Fossil, and Pegul. And I knowingly didn't choose to investigate any products that have been published before Git, because let's face it, these products have already been beaten by a newer product, being Git. So I can't imagine any product older than Git to still beat Git in the future. If that would be true, it should have happened already, and until now it hasn't happened. So in 10 years' time, either Git will be at the top or one of these 3 new ones, or a new one that doesn't exist right now, but I don't think it will be any of the older ones. You know, I don't think Subversion will be the top one, because right now it isn't even the top one. So let's talk about Plastic for a bit. This is a version control system that features fast branching, also like Subversion and Git. It offers merge preview, so if you want to merge a branch, it has a preview of it. You can continue with the merge, or you can abort it. You can operate it both centralized and distributed, so you can choose. And it comes with a lot of GUI stuff. In fact, this is one of its primary focus. It actually looks a lot like Git, but Git of course doesn't have the GUI stuff, the graphical user interfaces. And I researched this one a bit further, and I discovered that the graphical user interface part is because it is focused on artists and designers. So they have a special version control component, which they call Plastic Gluon, and it's a version control component meant for artists and designers. So if they want to work on a software product, and they need to create graphics or models, they can work with the version control system, the same version control system as the developers. There are also image diffing features. So if there are multiple versions of an image, there are a lot of tools to view the differences and see what changed. And it's no surprise, I think, that the references on their website, on the Plastic website, they are exclusively from game studios. So this version control system is focused on software development teams where a lot of different expertises are joined in a team. And if you're building a game, you don't only need programmers, but you need designers, you need artists. And if they all need to use the same code repository, it kind of makes sense to help them a bit to add graphical user interfaces to help their source code management, because maybe software developers are okay with using a console or a terminal application, but I can imagine a designer or an artist doesn't like to use that. So this is a preview of one of the image diffing components in the Plastic source control system. So in this case, you can see the different versions of this graphic, and you can use the slider to slide over the image so you can see what parts of the image had changed in what version. So I guess for game development, this is a great, nice system, but there are a few drawbacks, and I think these are the reason that they won't bring Git down. It's not open source software. Apparently the story of BitKeeper hasn't reached the people of Plastic. It didn't teach them anything. You need open source software to be able to conquer the version control system world. I guess this is what we saw with BitKeeper. And secondly, to me, it seems like Plastic offers a bit of eye candy graphical user interfaces for their version control system. And I think the existing Git users are not going to change their version control system just for that. Most of the Git users right now are already used to using the command line. And those who are not are probably using a web-based product, or they are using SourceTree or GitKraken. So I don't think they will change their whole version control system just for a bit of GUI tools. So I think this is not going to be the Git killer. So that means 2 systems left. And these are the more serious contenders. And first up is Fossil. Fossil is also a distributed version control system. And it also has integrated bug tracking, integrated wiki, forums, and tech nodes. It has a built-in web interface that you can host locally. And it has a so-called auto-sync mode, which means it pushes automatically after each commit. So you commit one and it tries to push your commit if you have a connection. If you don't have a connection, it will wait with pushing the commits until you have a connection again and ask you if you want to push it. And one of its major features is that it can show descendants of a check-in. Well, this is very different from Git because in Git, a commit only knows what the previous commit was, but it doesn't know what the next commit is. So it's like a one-way link. And it would be very hard in Git to get a list of the descendants of your check-in, you know, the children of your commit, because there could be a lot of branches in a lot of locations. Everyone could have cloned your repo and created more commits. And how do you know that those commits even exist? In Fossil, this is quite differently because this is done differently because Fossil has a doubly linked list to connect the check-ins and stores them in a relational database. So there's a lot of more focus on relations between check-ins. Fossil also can support operations on multiple repositories. For example, pull all repositories. This is also not possible in native Git. So some quick facts. Fossil was written in C and in SQL, and it is the version control system of choice for the SQLite project, which is a lightweight database that stores the database in a single file, which is included in a lot of software systems. And it markets itself as GitHub in a box because there's an integrated wiki, there's an integrated issue tracker. So most of the things that GitHub offer, you can use locally on your Fossil installation if you want. And there's free code hosting. There's the Chisel app where they host free Fossil repositories, and SourceForge is also capable of hosting the Fossil repos. Though the last implementation is a bit unorthodox, I investigated it a bit further, and because Fossil needs only an SQLite database to generate some static HTML, any hosting space provider could just host a Fossil repository. Just some SQLite database support needed. So if you would really seriously host a Fossil repository, I would choose Chisel. I think that's the better product. Now I told you about this before, but let's repeat it a bit. Fossil uses a relational database, and a repository is stored in a single SQLite database file. And it contains relations between check-ins to be able to produce both ancestors and descendants of a check-in. So this is the doubly linked list that I told you about. In Git, this is very hard. Also in GitHub, you can't easily see a list of ancestors. And in Fossil, you can. And it markets itself as GitHub in a box. You can use the command Fossil UI, and it will host a local web interface. It's like a fully featured developer website. You can also view the history of your project. So no more looking at log files in your console application. And I think, so it also has the wiki ticketing, bug tracking, like I told you. It has embedded documentation and technical notes. And there's also a forum in this web interface. So I think this makes Fossil well suited for startups and small scale projects. For example, the product SQLite uses Fossil just for this reason. They can host their own UI, they can use it internally. I think it makes it not a very good fit for large scale open source development, like for example, the Linux kernel, because everything that's on this slide really tells me you should use this locally and you don't need remote infrastructure if you don't want to use it. So I think it has a place in version control world. I'm not sure, just not sure it's very suitable for large scale open source development. Let's do a quick demo of Fossil so you can see how it works. So I'll switch to a terminal right now, and I'll create a Fossil repo right now. So let's change to this directory. There's nothing in here, so let's make a new directory. I call it demo, and let's also create a new repository. So you type Fossil, then you type new, and you create a repository file. And this is the SQLite database. Here we go. Fossil tells us, I've created your project. This is your ID. This is your server ID. This is your admin user. And there's a password. Initial password, but you can change it later. Now we have a demo file and a demo folder, and we need to connect them to each other. So let's change dir to the directory. And from this dir, we have to open a repository like this and connect it to the SQLite database file like this. And now they are connected. And you can see that there's one check-in, the initial, and the tag is trunk. Okay, so let's make sure that we create a new file. Not sure why this bar won't hide. Go away. Here we go. Now you can see it. Let's create a sample Java file. Why not? And let's add it to the fossil directory. Just an empty file, nothing special right now. You can also do it like this. Now it says I've added the sample.java. Oh, sorry. The command is not fossil lock, but fossil changes. Here it is. It says I've added sample.java, and now we can commit it. Fossil commit. We can do -m. We can also just type it like that, just like Git. I'll do -m right now, and I'll say add a sample. Here it is. There's a new version, and I can call status, and it says this is the current active checkout, which is the new version that was created right here, and its parent is this one. So here you can see that it keeps track of parents. Let's view the UI for a bit. So I can say Fossil UI. It will open a browser window. Where's my browser? Here it is. This is the Fossil UI that is hosted on your local machine if you start Fossil UI. And the first thing you see is the timeline, initial empty check-in. You can open these revisions and see what's in there. Of course, I didn't really add something that you can't see it really, but you can see that sample.java was added. And here are all the features that I told you about. The files that are present in the repository branches if you created them. This is the standard branch. If you have pushed any tags, there's a forum in which you can chat with your coworkers. You can create tickets. There's a wiki, all kinds of stuff. So this is all in the box. This is all included. Full developer website. I quite like it. Back to the presentation. Of course, there are also bad things with Fossil. I already told you that I'm wondering if this will scale well for a large project and also for an open source project. I found a blog from someone who used Fossil for quite some time and decided to replace it with Mercurial eventually. And he writes about it in this blog. So if you're interested, read the blog. It's about dealing with large files and large commits. This person encountered that with large commits, Fossil has some issues. Also because the whole database is just one file. So if this file gets too large, you get some problems. Also, it seems, if you read the blog post, that the garbage collect that Fossil has is not quite as sophisticated as the one in Git. You know, when you use Git on a daily basis, sometimes you see that it starts a garbage collect and it wants to create tag files from all your objects, entries and commits, and make sure that you can still keep working fast with Git. And this is not quite possible with Fossil, according to this blog post. So if you're interested, read it. If you still want to use it, go ahead, but make sure that you know about the drawbacks. Also, if you're used to Git right now and you want to use Fossil, then read this wiki page because it's great. It's meant for Git users and also about translations from Git to Fossil and what you should be heading for and what translations you need. The last version control system that I want to talk about is Pijul. And Pijul is, well, for starters, it's a Spanish word, so that's why you have to pronounce it like that. And it's a bird from Mexico, a native bird from Mexico. The word means a bird from Mexico, and it's known to do collaborative nest building. So this is, I guess this is the reason why they chose the name, bird that collaborates when they're building a nest. And this is a photo of a Pijul. So what are the features of the version control system? It's distributed version control, of course, like Git and also Fossil. And it tries to keep things very simple because it's based on a sound theory of patches. This reminds me of Darks. Darks was a version control system that started in 2003. That's also patch-based. However, it never got very popular because it was very slow. And Pijul says we've taken the best things from Git and from Darks to make sure that there's a patch-based system that can also be fast. So that is the basis of the system. So this, I told you already, this one, it aims to fix the Darks performance issue. So it's also fast, and it features interactive recording. There'll be a demo in a bit, and I'll show you how this works. Some quick facts about Pijul. It is written in Rust, and Rust is one of the faster languages around because it's a much lower level language than, for example, Java. So performance is a bit better. It's been bootstrapped since April 2017, and with bootstrapped, I mean that it has been used for its own development. You know, the best software systems, like for example, IntelliJ, is also used for its own development, and people of Pijul also use Pijul as their version control system. So I like this fact about software systems. If you use it yourself, then of course you think it's good enough. So there's also free code hosting. It's called the Pijul Nest because of the birds, obviously, and you can create your free public repositories in there. So this patch-oriented design, what does it mean? Well, they say a patch is an intuitive atomic unit of work. You can apply a patch or you can unapply a patch, but no strings attached. So a unit of work is always this patch, and it focuses on the changes and not on differences between snapshots. So in contrast, Git doesn't store any patches. If you ask Git what's the difference between these 2 points in time, it will calculate them in real time based on your request of Git diff. Pijul stores the changes. So that's quite different. Git is called a snapshot-based version. It just stores snapshots, points in time, and calculates the differences. Pijul stores the changes. This is a pro of this approach. If you apply a patch or unapply it, doesn't change its identity at all. So it will still be the same patch. There won't be a new snapshot because it's not a snapshot-based system. It's a patch-based system. Which also means that the end result of applying several patches together or sequentially, and the end result will always be the same regardless of the order in which they were applied. It's a bit like simple additions formulas. Like if you want to calculate 3 plus 2 plus 5, the answer will be 10. And if you do 5 plus 3 plus 2, the answer will also be 10. So this is the basis of the Pijul patch-based system. If you apply patch A, then patch B, then patch C, you get an end result in which patch A, B, and C are all present. And if you first apply C, then A, then B, the end result will be also the same. And in Git, this shouldn't always be the case. Couldn't always be the case, but in Pijul it is. So how does it keep track of, for example, a new file created in patch A and then the new file is edited in patch B? You can't just first apply patch B and a modification of a file that isn't even present if you don't have patch A applied. So it keeps track of dependent patches. So every patch has a field in itself that says I'm dependent on another patch. So if you apply patch B, then you first have to apply patch A, and then you can apply patch B. So if you would tell Pijul to apply patch B, patch A is applied automatically, and then patch B. And every patch has this list, a kind of graph, dependency graph. It says first apply all these patches, and then you can apply this one. This means that Git doesn't need any merges or doesn't need any rebases. They just apply patches like Git cherry pick, but Git cherry pick also changes the identity a previous commit is like recorded and replayed and copied as a new commit. In Pegul, it's the same patch and it's just applied. So let's do a quick demo of Pegul. I've lost my terminal. We start another one. Ah, here it is. I just minimized it. It's still running the fast UI. I have a folder Pegul. Nothing in it, so let's initialize it. I will say init demo. So there's a demo. There's a demo folder like this. Nothing in it. I can ask the status right now, and it says just like Git. This is a lot like Git output. On branch master, but nothing to record. Working tree clean. So let's create a sample file. And let's add it. Status says changes not yet recorded. New file sample Java. Use Pegul record to record a new patch. One difference with Pegul in comparison to Git is that it also can add directories. So in Git, Git doesn't keep track of directories, they just keep track of files and they store in which directories they are. And if you want to add an empty directory, you have to put a file in it or a git keep file. In Pegul, directory is also a file, and you can just add a new directory. So let's test it out. I will create a directory called directory, and I'll just add it. Add directory. Ask for the status again. It just says new file directory. Yeah, why not? So let's record it. The command is called record and not commit, but it works the same like in Git. I can record, and here we have the interactive record mechanism. In Git, if you have multiple additions or an addition and then a modification, you have to add them separately or at the same time if you want, but you have to add a file, add it to the commit it, then modify it if you want to keep these things separately. Pegul will ask you, do you want all of these in the same patch, or do you want to separate them? And the first thing it will ask you is, shall I record this change? And you have to give an answer. And there are kind of shortcuts here. These are, you can see the letters here. So a Y means yes, I want to record this change. If you type the N for no, it means you won't record it, so your patch will be aborted, or this part of the patch will be aborted. A few more options. If you do A, it means yes to all, so everything will be added. If you do an I, it means add to the ignore list. So this interactive one is quite powerful. So I want to record this change, and I want to record this one also, and it will record it. And it will ask, what is the name of this patch? Well, I will tell you, it is add a sample. And it recorded the patch, and it tells me right now. Oh, so see what I did there? Oh, I typed git. Oh, I need to get that out of my system. Maybe also define an alias for Pegul because it's quite a long word. Let's ask for the status again, and the working directory is clean again. Now let's make this sample Java file a bit more interesting, because there's nothing in it right now. So I'll start up my Finder, and let's see if I can find the file that we just created, Pegul demo. I'll open it with VS Code, and I'll give it a quick implementation. VS Code, where are you? There we are. So let's create a public class sample. Public static void main string args. Don't forget this one. And let's just print something to the system out, a random number. I'm just typing this so that we can view the differences later on, just to have something. So let's generate a random number. Well, good thing I brought my die. So let's just roll it and guarantee it to be random, right? So I'm rolling it right now, and it says 3. So let's return 3. Chosen by fair dice roll. Guaranteed to be random. So let's save it. Let's return to the terminal. Sample Java. Let's run the Java file. I'm using a Java 11 feature here called single file code execution. I like it. And it says 3. Well, that's great for a first implementation, right? So let's add this to the Pickle repository. Add status, add sample Java, and we'll say Pickle record, and we'll ask us, shall I record this change? Yes, this is the new implementation. This is the good one. Add good implementation. We are, and we recorded another patch. Now I want to show you what happens if you unrecord it. So I can ask Pickle for the log, and here are the patches that were applied. But as I explained to you already, a patch is in a single atomic unit of work, and it can be unapplied just as easily. And it doesn't change the identity one bit. So with Git, if you revert a commit, it's another commit on top that inverts it. If you really want to delete a commit, it's quite hard. You have to do a bit of nifty commands, and then you can make it work. But you have to change the history. In this case, well, it changes the history, but the history is not really set in stone. You know, you can change it because it's just a stack of patches. So in this case, I can tell Pickle to unrecord. Well, I can do two things. I can supply the hash if I know them, not by heart, of course. They're very long, but I can. This command is also interactive, so I can just hit enter right now, and it will ask me, "This is the first patch I see. Do you want to unrecord this one?" Well, yes. As a matter of fact, you guessed right. I want to unrecord this one, and now it's unrecorded, and seems like I unrecorded 2 patches. That's interesting, but I think it can be done. And all the changes that we unrecorded are now the new files. So we can record them again if we want. If we didn't mean to do this in the first place, and all the changes are still there, I can record them again. And the number implementation. And it's recorded again, and I can look at the log right now, and now it's 1 patch, but this is because we unrecorded 2, and we merged into 1 effectively. Still the same features, and there's a different hash, but we can just still apply them, and nothing. It feels very dynamic to me. I really like it. Just one more bit for the demo. I have the slide deck that I've used until now. I created it with Reveal.js, which is an HTML-based presentation framework, and I kept the presentation also in a Pickle repository. So this is the root of my presentation project, and I can call Pickle status on this one also, because this is also a Pickle repository. And you can see I just generated a PDF file, so that everyone who attended the talk or watched the talk can view the slides later. I deleted a few things. I modified something apparently. So I'm going to add this to the repository and push it to the remote on the Pickle nest so that I can show you how this works for a bit. So let's say Pickle add startup PDF. no matches. We can just add everything. That's no problem. In Pichul, when you add something and it's in the subdirectory like this, it's in the subdirectory PDF, you have to add the recursive flag. I forgot about that. Now it's okay. And we can record it. Pichul record. Everything is recorded. And what's the name of this page? Add PDF for the Luxoft Tech Talk. This could take a while because these PDFs are quite large. They're like 80 megs or something. So here we go. It has been recorded. If I want to push my local to the remote, I just call push. I have configured a remote. You have to do this the first time. Right now it's okay. And it says pushing to branch master. I need to fix my SSH configuration. And it wants the password for the Pichul nest. I can ask my password manager this. No, not like this. Copy the password. There we go. This is a very nice feature that we're seeing right now. Now it's going to ask me, which patches do you want to push? This isn't present in Git at all. You just synchronize the stuff and, you know, hope for the best. And if you want to separate these changes from other changes, just create a new branch. And there are a lot of branches and you need to merge them, rebase them. But with Pichul, you can just leave a few patches on your local machine if you want and push them later. It doesn't matter to Pichul because you can just stack them. Almost no merge conflicts. So in the documentation of Pichul, they say you can create branches with Pichul, but right now in the talk, I'm deliberately not showing you because in a lot of cases, you don't even need branches because you can just choose to. If there would be 2 branches like right now or 3, I could just push the one and leave the other ones until I think they're ready or they need new patches or something. In this case, I'm going to push it, but you can just choose it. Well, there are a lot of more patches. I could have just chosen no for a few of them to be able to work on another feature and decide when it's ready later. This one is also going to take a while because, as I said, the PDFs are quite large, so you need to upload a few things. In the meantime, I will show you the Pichul nest project that I made, which is this one. The link will be on the final slide if you want to watch it. This is how it looks. It's quite basic, but it has all the functionality you need, I guess. It looks a bit like GitHub, of course. You have the file browser here. Branch selector, I haven't used any until now. And patches are just a diff view. Apparently the push is still happening, so I don't see the new ones, but I think it will come very quickly. Maybe at the end of the talk, I'll show it one more time. For now, I'll return to the slides. Let's wrap it up a bit. So of course, Pichul also has some bad stuff. Every new software system has, I guess. Here's a blog post from someone who has used it for quite a while. And this person says, I really like it. It has some potential, but the usability needs to be improved. Some things don't feel ready for production. That's not a shame because Pichul's current version number is 0.12. So they aim to create a 1.0 version in due time. The basics look quite promising, I think. If you want to switch to Pichul from Git, there's also a good checklist. If you use the Git, you can see the translations of the commands and all kinds of things. So on to the final predictions. It's prediction time. Let's review our prediction variables. I said killer features, hosting platform support, open source community support, and the disadvantage of the dominant product. What I will do is I will score all the version systems that we saw today on these 4 variables, and I'll give them a score of 0 if they'll stay the same, +1 or +2 if they will be better, -1 or -2 if they'll be worse. So based on killer features, I think Pigul is the best one. Its major feature is fast patch-based versioning. I think this one might lure new users to it who think Git is a bit too difficult to understand with all these snapshots and rebases and mergers have gone wrong. Fossil just adds show the sentence and an integrated developer website. I think that's a bit less killer features. So yeah. Hosting capabilities, well, the hosting capabilities for Git are outstanding, of course. Wikipedia says there are 16 different websites that support Git repositories. Mercurial has 9 websites that host. TFS is only 1, which is Azure DevOps. And Fossil and Pigul both have 1, but I think it will grow in the future. So I scored Git +2, Mercurial +1, TFS -1, and Fossil and Pigul 0. Then the open source support, of course, Git and Mercurial, they have proven that they contribute massively to open source development. TFS just doesn't. And I'm not really too impressed with Fossil on this one because they have a nice approach with their GitHub in a box and you don't need a dedicated hosting platform. But the consequence is that they are tailoring their product to small teams that are physically at the same location and not spread out across the world. And this is not the best support that open source development can have. And I think Pigul shows potential with the Pigul Nest, but it needs to become a lot more popular in the future, of course. And there are not a lot of repos right now. And the last prediction variable, the dominant product. Well, the dominant products will score less on this one, of course, because they are the dominant product and the other ones score 0. So if we summarize this, if we add it, then we see that we predict based on these variables that Pigul will grow the most, Fossil will stay the same, maybe grow a bit, TFS will lose, and Git and Mercurial will score also a +1. So what does this mean? Well, this was the first prediction that I made in the beginning of the talk, and Git will be 80%, Mercurial 9, TFS 7, and we need to alter these a bit based on the scores that we handed out here. So let's do a strike through, and this is the prediction that I'm coming up with. So I think that Git will gain a few users who now used to TFS. So I do this Git 1 course day multiple times in a year, and most of the time it's filled with students who now use TFS and want to switch to Git. So it will gain a few new users from TFS, and as a result, TFS will decline a bit further from 7 to 4%. Git and Mercurial will both lose some users to Pigul. People like me, who just the early adopters want to try it out, and maybe in a lesser extent to Fossil, maybe people who want to run their own hosting platform. I think based on these scores, Pigul will be a grower. I think they will be the 3rd version control system in 2029. But of course, I based this prediction entirely on the current hosting situation. What if GitHub announces next year that they are going to support Pigul? Then it will gain users a lot faster, might even become number 2. And if they decide to do this with Fossil, then of course Fossil will grow a bit larger. So can't promise anything, but if the things stay the same right now, I think Pigul will grow a bit. But of course, it's very hard to beat Git in these 10 years of time. And it also depends on these 2 systems and when they will be ready for production. Pigul is still in 0.12, so we need to wait and see about that. If you're really interested and want to read a bit further about this topic, this is the blog post that I first read that gave me the idea to investigate. And also, this is what I Googled when the student came to me with the question. So beyond Git is blog by Paweł Swiatkowski, who writes about what is next after Git. This is a blog from Joe Neiman, and he has used Pigul for quite some time, so it's good to read up on that. if you want to get started with Pigul. The manual is very good, so start there. Now, if this was a conference talk, I would ask the room if there were any questions. Of course, it's Tech Talk, so we can't do that. But feel free to reach out to me on Twitter. My Twitter handle has been on the first slide, it will be on the last also. So skip to that part and ask me a question on Twitter. I will be glad to respond. I've been using Pigul for this presentation right now. I'm planning to use it a lot more, just to see what it has to offer, if it really meets my expectations. So if you want to know about the usability or of the other systems, feel free to reach out to me. The slides are being uploaded as we speak. I think they will be there right now, the PDF versions on the Pigul Nest. Let's just give this a quick refresh. There we go. It has been uploaded. So here you see this patch. There's a PDF folder in my project where you can see the PDF version of the slides. Here they are. I did it in Athens also, now for the Tech Talk. If you use Reveal.js yourself, you can just host a presentation also if you prefer. That's the way to view the slides. This is my speaker website. You can see where I'm speaking on what topic. So if you like it, visit it. You can reach out to me on Twitter. You can email me at my info support email address. I will also answer there if you're interested. I hope I made you enthusiastic about the subject. I'll continue to try out the new systems, follow the development in the field, and if you want to know more, reach out to me. Thank you very much for your attention and for watching this talk, and I'm wishing you a great day. Goodbye.